All right, so this is your Unit 6 test review. Starting with areas. What is the area of the region between these two graphs from 0 to 3? So we're going to do integral 0 to 3. And I'm just going to make a very quick sketch. This one is non-calculator. If it has a little C next to it, that means on the test, the one that's like that is calculator. To be really honest, if you don't know which one is the upper and which is the lower graph, you can do it in whatever order you want. And if you get a negative answer, just absolute value it, or just don't put the negative. But if you want to do a really brief sketch, this is a parabola moved up 1. It's going to look something like that. Negative 2x is going to go through the origin and look something like that. And we're going from 0 to 3. So, roughly this is the kind of shape that we're finding the area of. So the upper graph is the parabola, lower graph is the line. So I want to do x squared plus 1 minus negative 2x. So negatives are going to cancel. Non-calculator, so we're going to have to actually work it out. We're going to put the antiderivative. And we really just need to plug in 3. Again, don't always assume the lower boundary is, if it's 0, that it's going to give you 0. But in this case, if you plug in 0 to all these, you will get 0. So 3 cubed is 27. A third of that is 9. Plus 3 plus 9, so 21. All right, write but do not evaluate an integral to show this area. So we're going to go from A to D, where the intersections are. And it's upper graph minus lower graph. So g of x is the upper one, minus f of x is the lower one. There's just a lot of unnecessary information in that graph. This is, pretty noisy, and you just have to filter out everything that you don't need. All right, R is the region bounded by square root of x. Again, I'm just going to do a really brief sketch. Square root of x would look something like that. Vertical line, x equals 7. Write an integral to show the area both as dx and dy. So when I do x, I'm going to do 0 to 7. When I do y, I'm going to do 0 to whatever this output value is, which is going to be square root of 7. If this is your graph of square root of x and it's intersecting with 7, that's going to be square root of 7. Just going ahead and putting it there now because we are going to need it. So to do dx, it's going to be from 0 to 7, upper graph minus lower graph. It would just be square root of x. The lower graph is the axis, so that is 0. So it would look like that. And then if we want to go the other way for a dy problem, again, it'll be 0 to square root of 7. I want to do right minus left. I'm going to have to rearrange this and square both sides. So this is my left graph. The right graph just is 7. So it's going to be 7 minus y squared dy. So it's just being able to write it both ways. What is the area? Take 2. What is the area of the region bounded on the left by this and on the right by this? So I don't really need to draw a graph. They told me which one is left and which one is right. And these are y values. So they gave me everything. I'm just ready to set it up. So integral 1 to 3. I want to do right minus left. So 3y minus 8 minus, I'm going to write that as 1/4 y squared so that I have a fraction coefficient. Non-calculator, so we're going to have to fight our way through this, right? So 3/2 y squared minus 8y minus 1/12 y cubed. You would want this to be 1/3 y cubed, but there's already a 1/4 there. So 1/12. Integral 1 to 3. We did not luck out and get one of the boundaries to be 0. So again, we are going to have to fight the whole way through this. Plugging in 3. 3 squared is 9. 9 times 3 is 27. So 27 halves. 3 times 8 is 24. 3 cubed is 27. And then we want to do twelfths. So let me see. 27 twelfths. They'll both divide by 3. So that would be 9/4. Just wrote it off to the side so that I could see it. All right, now plugging in 1, that's going to be 3/2 minus 8 minus 1/12. Actually, now that I'm looking back at this, I probably would want it to still be twelfths so that I can combine those together. So actually, I'm going to just write it as the 27 twelfths. So I can have, like terms, so to speak, because we're going to have to keep on going. All right, first thing I'm going to do is distribute this negative sign. So it's going to be minus 3/2 plus 8 plus 1/12. And then I'm going to combine what I'm calling like terms together. 27 halves minus 3 halves is going to be 24 halves, which would be 12. I have negative 24 plus 8 would be negative 16. And then I have negative 27 twelfths plus 1/12 would be negative 26 twelfths. Making sure that I did all of that correctly. Does that look right? Yeah, okay. So 12 minus 16 would be negative 4. This is going to reduce down to, well, those both divide by 2, so 13/6. And I believe they leave it like that. Let me look at my answer key real quick. Yes, so whenever you boil it down, they don't go an extra step and get a common denominator. Your answer choices are going to look like this. So you can just leave it like that. Basically, if you get close enough to the right answer, you'll be able to pick A, B, C, or D. I don't like that problem, but that doesn't mean I'm not going to give it to you. We can't avoid the ones that we don't like just because there are a lot of fractions. Sometimes you have to fight through it to get the right answer. All right, I'm going to need the calculator for this one. K is between 0 and pi over 2. Area under the curve, sine of x from K to pi over 2 is 0.3. So they're giving the answer for the area and asking what one of the boundaries is. So we want to go from K to pi over 2, area under sine of x, and they're saying that that is 0.3. So antiderivative of sine is negative cosine. We're going to do upper minus lower. Oops. I tried to do a parenthesis and a 0.3 at the same time. I'm hurrying because I'm upset at myself that I didn't post this already. All right, upper boundary. Pi over 2 is at the top of your unit circle. That's up here. It's the point 0.01. Cosine is the x part of that point, so that's going to be 0. I can't negative a 0, so the whole thing is just 0. If you plug in k, you're just going to get negative cosine of k. So here's where the calculator comes in. These negatives are going to cancel. It's going to be positive. I'm going to type in cosine. I'm going to type x when I go to type it in, but cosine of x and then 0.3, and I'm going to see where they intersect. All right. Also, make sure you're in radian mode. Mine should be because I haven't changed this at all. But yeah, radians is the default. If you are in a class where you have to change to degrees, though, make sure that you change it back. All right, so I'm going to type cosine of x and then y equals 0.3. If you just type 0.3, it won't show up. You have to put y equals to make the line show up in there. Now, there's a whole awful lot of intersections. I know it's this one because it said in the problem k had to be between 0 and pi over 2. So I know it's going to be this first one here. So this is our answer, 1.266. So even though that's a calculator problem, you still had to actually do some work. You had to do an antiderivative, upper minus lower, and then you can put it in calculator. All right, this one is also calculator. We want the area enclosed by those graphs. To be real honest, since this one is calculator, I'm going to just go and use the calculator right from the get-go. So let me share my screen again. So I am going to type in both of those equations. So I've got x cubed minus 8x squared plus 15x. And then the other one is 3x. So move this down a little bit. I want the area from 0 all the way over to here. You actually get two spaces enclosed by this graph. You get this one, and then you also get this whole area here enclosed by these graphs. So I want to go from 0 all the way to, let's see, 6. So I'm going to do integral 0 to 6. And the way I'm going to make it not matter which one is the upper and which is the lower is I'm going to absolute value it. So x cubed minus 8x squared plus 15x minus 3x dx. All right, so 49 1/3. All right, so that's done with areas. Now we're on to arc length. Set up, so we're not going to have to actually work it out. The integral that gives the length of the curve x squared, or is it, no, x to the 7th, from 2 to 9. So we're going to go from 2 to 9. It's going to be a big old square root. Again, set it up blank. You're going to have 1 plus the derivative squared. Derivative of this would be 7x to the 6th. Remembering this one now, they are going to actually square this stuff though. So I'm going to do one more step. I was thinking about erasing it, but I'll just write another step. So 7 squared is 49, and x to the 6th squared would be x to the 12th. When you do a power to a power, you multiply them. So that is what your answer choices will look like. This one's calculator, so we're going to set it up and then go put it in the calculator. So we want to go from 0 to 2 pi. Again, set it up blank. It's going to be 1 plus the derivative squared. So derivative of 2, that's a constant, that's going to just go away. Derivative of sine is cosine. And so I'm going to just put this in the calculator. Again, make sure you're in radians. Anytime you do trig, you're going to need radians. All right, 7.640. All right, on to cross sections. Base of a solid in the first quadrant between the graph of x cubed and the x-axis. So I know x cubed is the upper graph and the x-axis is the lower graph. You can graph it if you want to, like just do a quick sketch of, over here. But I know that that's like the wiggly graph, and then I've got the x-axis. From 0 to 2, perpendicular to the x-axis, so it's going to be dx, and we have a semicircle. So I know the base of this is going to be x cubed minus 0, so just x cubed. And then I can go ahead and set this up. It will be integral 0 to 2. And inside of there, you put the area of your shape. So it is 1/2 pi r squared is for a semicircle. And the most common mistake is taking this x cubed and putting it in there. That's not the radius, it's the diameter. So you have to do half of that. This one is non-calculator, so we're going to have to keep on going. I'm going to take this pi over 2 and just, put it out front for a minute so that my integral is less cluttered in here. X cubed squared is going to be x to the 6th, and then 2 squared is 4. I'm actually going to just go ahead and write that as a 1/4. You can write x to the 6th over 4 if you want. Again, all this boils down to his personal preference. I'm actually going to choose to bring this 1/4 outside as well. That would be pi over 8. And then your antiderivative for x to the 6th would be 1/7 x to the 7th. We want to go from 0 to 2. Plugging in 0 is just going to give you 0. So really, we just need to plug in 2. So let's see. I'm going to just count on my fingers. So we get 2, 4, 8, 16, 32, 64, and then 128. So to the 7th would be 128 pi. And then if I multiply 8 times 7, I get 56. That is going to reduce, though. I think we'll both divide by 4. That'll be 32 pi over 14. And that'll actually reduce again. Those will both divide by 2. So 16 pi over 7. All right, next to our calculator. So we want area between the graphs of x squared and 2x. We want to be perpendicular to the y-axis, so I am going to have to rearrange these. What is the volume? So we are going to get x by itself here. We're going to square root. For this one, we're going to divide by 2. And since this is calculator allowed, I'm going to go ahead. I'm going to draw my square here first. I'm going to go ahead and graph them so we can see which is the right and which is the left. And if you can figure that out without having to graph it, like if you can kind of hold what those graphs will look like in your mind, then more power to you. All right, so what was the first one? X squared And then the other one was 2x. I'm going to hit the home button since I had moved this around a little bit. All right, so the blue one is the right graph, and the green one is the left graph. So the right one is the curve. Now this says x squared, but when I write it on my paper, and you guys can just kind of look right. Can I make this bigger? Oh, I can. All right. It's going to be that square root of y. So we'll have square root of y minus y over 2. And then we're ready to set up our integral. I need to look at my graph to get my boundaries. I want them to be y values since it's a dy problem. So it's going to be from 0 to 4. All right, 0 to 4. And I want to put the area of my shape in there, which is a square. So it's going to be square root of y minus y over 2 squared dy. And then I am going to type that in. And it's super fun to watch me typing things. But I want to get a numeric answer so you can practice typing it as well, and make sure you can use the calculator because that is an important skill. All right, 0.5333333. All right, this one is also calculator. We want bounded by the graphs of 4 minus 4/3 x, and in the first quadrant, right? Perpendicular again to the y-axis. So I'm going to have to rearrange this, a rectangle with the height 3 times its base. All right, so first thing I'm going to do is the algebra for rearranging this. I'm going to subtract the 4. I'm going to divide over the negative. And then to cancel out a 4/3, I'm going to multiply both sides by 3/4. So distributing that through, we'll have negative 3/4 y plus 3. The 4s are going to cancel there. All right, so that is going to be the base of our shape. Got a little too close to the bottom of the paper there. And then the height is going to be that times 3. So the height is 3 times the base. So let me see. I need to type this in so that I can see what my boundaries are. Sorry, every time I have to use the calculator, I have to share my screen, so it's a lot of typing, clicking back and forth, so I apologize for that. All right, so it was 4 minus 4/3 x. And I want y values for my boundaries, so it's going to be 0 to 4. I should have realized that. That's the y-intercept. And so let me pull this back up here. So 0 to 4, and I want the area of my shape to be what goes in here. So this is the base. Again, the height is 3 times that. So I want to have 3 times that stuff squared. You can write it out twice if you want to, but this is less writing and a little bit cleaner. All right, and it comes out to 36. All right, now we're on to disks. This is volumes of revolution. So we have a triangular region in the second quadrant with these vertices. Let me go ahead and draw a quick sketch of this. So 0, 0 is the origin. Negative a, 0 would be right here. And then 0b would be right here. So this is this triangular region that we've got. We don't have any actual numbers. They just gave us a and b. We want to write an integral for the volume when we revolve around the x-axis. So this would be our ghost shape down here. It's going to be pi r squared dx. We want to set it up blank. We're going to go from negative a to 0. And if you even get the boundaries, that's going to help you narrow down your choices. And then in here, it's going to be upper graph minus lower graph. The lower graph is the axis, so it would just be 0. We just need an equation for this. If you want to go back to y equals mx plus b from algebra 1, our slope, we go up b over a. So b over a x. And if you're like, well, why isn't it negative? Because this line is increasing. It's going up. We have a positive slope. We go up b over a. And then the y-intercept is b. Set it up blank so you don't forget the squared, although it's multiple choice, so hopefully you won't forget the squared. All right, what is the volume generated when we revolve y equals x and the horizontal line y equals 4 and the y-axis around the line y equals 4? I need a picture of that. I'm going to need to see what that looks like. All right, y equals x is going to just be this line. It goes through the origin, slope of 1. Horizontal line y equals 4 is going to be right here. They're going to intersect at 4, 4. So right there. And the y-axis. So this is our triangular shape. And we are revolving around the horizontal line y equals 4. So this is the line that we're revolving around. I'm going to erase my tails here. So this is our line of revolution, and we're going to spin around that. So it's going to be pi r squared dx. It's like we just took the x-axis and scooched it up a little bit. So revolving around a horizontal line is going to be dx. We want to go from 0 to 4, and it's going to be upper graph minus lower graph. So your upper graph is 4 minus your lower graph, which is x. This is non-calculator, so you're going to have to actually work it out. The only way to multiply this together when you have something squared is to do it twice. You have to distribute everything together. There's not a shortcut to that, right? 4 times 4 is 16. If you distribute here, you get minus 4x. If you distribute here, you get minus 4x. So minus 8x, and then negative x times negative x will be positive x squared. Antiderivative will be 16x minus 4x squared plus 1/3 x cubed. I can get away with not plugging in 0 since that's going to just give us 0. So I'm going to just plug in 4. So let's see, 16 times 4 would be 64. 4 squared is 16 times 4 would be 64. Okay, so that's convenient. Plus 4 cubed is 64. So 64 thirds. These cancel, which was really nice. So 64 pi over 3. All right, next one. What is the volume of the solid generated region in the first quadrant bounded by e to the x? So that is going to be our swoopy graph. And the vertical line, x equals ln of 5. I know it's going to be over here somewhere. I don't know how much ln of 5 is without a calculator, but, you know, that much. And we're going to revolve this around the x-axis. So drawing my ghost shape down here. It's going to look kind of like a tree trunk, I suppose. It's going to be round and 3-dimensional. So we're going to do pi r squared dx. We're going to go from 0 to ln of 5. Again, however much that is. And it's upper minus lower, but the lower graph is the axis, which is 0. So it's just going to be e to the x. When you have e to the x squared, you can write that as e to the 2x. So it's technically a u substitution where u equals 2x, but to cancel out the 2, we're just going to put a 1/2 in front. So it's going to be 1/2 e to the 2x. E is its own antiderivative, such that 0 to ln of 5. Oh, this is a perfect example of you can't always assume that just because the lower boundary is 0 that you're going to end up with 0. The two I always remind everyone are e to the 0 is 1, and cosine of 0 is also 1. So those are the two that you need to in particular be real careful about. So plugging in ln of 5, you can take the 2 and put it back as the exponent. If you have, let me do a little margin problem here. If you have 2 ln of 5, you can take this 2 and put it back as the exponent, and it's going to be 5 squared. So it is actually ln of 25. That happened in pre-calc, whether you remember it or not. If you don't remember it, it's fine. It's super easy. You just put this here as the exponent. 5 squared is 25. All right, so plugging that in, we're going to get 1/2 pi, or pi over 2, e to the power ln 25. E and ln are going to cancel, so it's going to just end up being 25. And then when I plug in 0, e to the 0 is 1 times the rest of this is just pi over 2, or 1/2 pi. So this one is 25 pi over 2 minus 1 pi over 2, which is 24 pi over 2, and 24 divided by 2 is going to give you 12. This one is calculator. We want the graph 1 plus sine of x, and we want to revolve around the x-axis. I'm going to just go ahead and type it in since it's calculator allowed. I feel like you get to use your calculator a whole lot more with this unit than any of the other ones we've done so far. All right, so what was it? 1 plus sine x. And the x-axis, right? It says region in the first quadrant. So we want to go from 0 to 3 pi over 2. So let me bring this up here so you can see what I'm writing down. So we want to go from 0 to 3 pi over 2. I'm going to set it up blank. Pi r squared dx. And our radius is just going to be that equation. Oops. All right, 28.489. All right, next one is also calculator. So I am going to just go ahead and type that in as well. Right, x equals square root y plus 1. And then let's see, we have that. The line x equals 0, so it's just going to be the y-axis. And y equals 3, I'll just type that in for good measure. So, this area right in here. And we are going to revolve that around the y-axis. So your ghost shape would be kind of over here. So we want to go from -1 up to 3. We want our boundaries to be y values. And here, let me set it up blank. It's going to be dy. So we want to go from -1 to 3. And it's going to be right graph minus left graph. Your right graph is this equation, this square root of y plus 1. Your left graph is the axis, which is 0. All right, so there we go, 25.132. I guess I didn't really write much down there. You don't really have to write anything down, though. If it's calculator and you did the whole thing in the calculator, it's going to be multiple choice. So you don't really need to show any work. If it happens in the calculator, then that's where it happens. All right, washers. These are going to be the ones that have holes in the middle. So we have the region enclosed by sine of x and the x-axis from 0 to pi. Just to give you a little picture of what that is going to look like. Sine starts at the origin. There's pi over 2, pi, 3 pi over 2, so on and so forth. We're going to be up here at 1, down to 0, down to -1, and it's going to keep waving from there on out. Mine's not very even, but good enough. We want this amount of it, just the one arch of it, from 0 to pi, and we want to revolve around the line y equals -2, which is going to be down here. My ghost shape is going to go all the way down here, so I'm not going to draw that because it's going to encroach on the next problem. But just imagine this circular thing with a hole inside of it. So we want to set it up blank. It's going to be dx. It's like we just took the x-axis and scooched it down a little bit. We want to go from 0 to pi. We don't have to actually work this one out either. It just says to set it up. So for the outside radius, the bigger one, it's going to be sine of x minus -2. So it'll be sine of x plus 2. And then the inner radius is going to be 0 minus -2, which is just going to be 2. And that's what your answer choices will look like. It says to set it up, but you don't have to actually work it out. All right, so we've got graphs. Oh, I remember this problem. This one's going to be a good bit of work, just as a heads up. That's why I've got so much space here. Y equals 3x plus 4, y equals x plus 4, and then x equals 3. Let's go ahead and draw that, or at least, a quick sketch so we can get a visual. We're going to go up 4. This one has a slope of 3, so it's going to be steeper. This one only has a slope of 1, so it's going to be less steep. And then the line x equals 3 is your vertical line here at 3. So the shape we're looking at is this. So you have a steeper line and a less steep line, and they have the same y-intercept, and then you've got this vertical line at 3. I guess I can erase this part. And we want to revolve that around y equals 1. So right here. So my ghost shape would be, I don't even want to try to draw this. It's not going to turn out good. It'll be down here. Imagine this spinning around. I can't draw it. It's not going to turn out good. But this triangle getting revolved around y equals 1. All right, we're going to set it up blank. This one, unfortunately, does not say set up, but do not evaluate. We're going to have to actually fight the whole way through this. Again, dx, it's like we took the x-axis and just scooched it up a little bit. So your outer radius is going to be this steeper graph, which is this 3x plus 4 minus 1. So I'm going to just go ahead and write 3x plus 3. It's 3x plus 4 minus 1. It's upper minus lower. And then the inner one is going to be this less steep graph, minus 1. Again, upper minus lower. So x plus 4 minus 1. I'm going to just go ahead and write x plus 3. Oh, boundaries. We want to go from 0 to 3. So the reason I say this one is more difficult, or maybe not even difficult is the right word, but just more annoying, is you have to do a whole bunch of algebra. 3x plus 3 squared means you're going to have to do this. And it's a lot of 3's. 3x times 3x is going to be 9x squared. Distribute these, you're going to get 9x. If you distribute these, you're going to get 9x. So together is 18x, and then 3 times 3 is 9. Minus, parentheses, and we're going to do the same thing with this one, x plus 3, x plus 3. When you square it, you have 2 of them. X times x is x squared. This will give you 3x. This will give you 3x. Together is 6x, and then 3 times 3 is 9. I'm going to go ahead and just erase to distribute this negative sign. It's going to turn all of this negative, and then we're going to combine like terms. I still didn't even do the antiderivative. I'm still writing this integral because I didn't even do the antiderivative yet. I haven't even done any calculus. This is all algebra. All right, 9x squared minus x squared will be 8x squared. 18x minus 6x will be 12x. And then, thank goodness, the 9's are going to cancel out. And now I can do the antiderivative. So this would be 8/3 x cubed plus 6x squared, such that 0 to 3, and I really just need to plug in the 3. So 3 cubed is 27. 27 divided by 3 is 9, and then 9 times 8 is 72. Divide first, divide by the denominator, and then multiply by whatever the numerator is. It'll keep your numbers smaller. And then here, 3 squared is 9, times 6 is 54. And then so adding those together, what is that? 126 pi. Phew. All right. We made it through. I would say that's the hardest one on the whole test, in my opinion. It's a whole bunch of algebra. All right. We've got graph y equals 2x. Oh, it even says above and below. Above by y equals 2x, below by x squared. So I don't even really need to draw a picture. I know which one is upper and which is lower. Also, I don't even need to work this out. It just says write the expression. We want to rotate. Oh, I am going to have to rearrange everything, though. We want to rotate around the vertical line, x equals -4. So, you know what? Actually, I will go ahead and draw it because it's going to be a dy problem since we're rotating around a vertical line. So y equals 2x is going to go through the origin, slope of 2. Y equals x squared is going to be a parabola. So something like that. I want to take this little, leaf here, this little like flower petal type shape. And we're going to spin around the vertical line, x equals -4, which is here. So your ghost shape is going to be on this side somewhere. You're spinning this way. So it is going to be a dy problem. And I'm going to have to rearrange these equations. So for this one, I'm going to divide by 2. And for this one over here, I'm going to have to square root. All right, boundaries are going to be y values, so I want to do 0 to 4. Outside radius, the one that's further away is the curved one, so that's going to be the square root. So square root of y, it's the right graph, minus the left graph, which is the -4. So minus -4 is going to be +4. And then same thing with the inside one. We want to do right minus left. So it'll be the y over 2 minus -4, so +4. And again, thankfully, we don't have to work it out because it just said to set it up. And then your last one is a free response, and it is calculator allowed. R and S are in the figure defined as follows. R is the region in the first and second quadrants bounded by these graphs. So R is all of this. S is the region only in the first quadrant. So S is just this part. So R is all of that. S is just this part. We're given 5 minus 2x squared. That's the upside down parabola. 3 to the x is the swoopy thing. Here we go. Find the area of S. You're going to have to split this into 2 separate integrals. It splits right here at 1. So if I go from 0 to 1, I want to be underneath the swoopy graph. That's the 3 to the x. And then if I go from 1 until this intersection, which I'm going to have to type that in the calculator to get, we are underneath the parabola, which is the 5 minus 2x squared. So I need my calculator for a couple of things. First, I need to get this x-intercept so that I have my upper boundary, and then I'm going to type the whole thing in. So again, we're underneath the exponential from 0 to 1, and then we're underneath the upside down parabola from 1 till whatever that is. So let's go ahead and type it in and see. All right, so we had 3 to the x. I'm going to just type all of it. And then we had 5 minus 2x squared. So I need this value, 1.58114. I'm going to copy that. And I'm going to put it right here. Oh, shoot, what was it? 1.58114. So now I'm going to type in the whole thing. There we go, 2.757. All right, B, find the volume generated when R, so now we're looking at this region, is rotated around the horizontal line y equals -3. So your axis of revolution is all the way down here at -3. Your ghost shape would be all the way down here as it spins around. You can see the little penguin through the paper. I just noticed that. So I'm not going to draw the ghost shape down here because it's going to take up like the whole paper and it's going to be huge. But there is going to be a hole in the middle. So when we set it up blank, it is going to be the washer method. So I need to get my boundaries for these intersections for R. I know this one's going to be 1, but I need to get this one. So I'm going to go back to the calculator for that. units. Let's see, that one is negative 1.581. I'm going to copy that. Bring this back up so you guys can see it. I just wrote it right there. All right, so to get our outside radius, it's going to be this one that's further away. That's the parabola. So the 5 minus 2x squared. Upper minus lower, so minus negative 3, so plus 3. And then this is going to be the same thing, but with the one that's closer. So 3 to the x minus negative 3, so plus 3. Now I'm going to type that whole thing in. All right, 246.090. That's not surprising, though. It's a larger shape. And when you spin it around an axis that's kind of further away, it's going farther. So you're getting a larger object. And we're finding the volume. So you have to remember it's three-dimensional as well. All right, last one. R is the base of a solid. We want cross sections perpendicular to the x-axis. Isosceles, which means two sides are the same or congruent. Right triangle with one leg in the base of the solid. So if one of the legs is the base, it means it's going to look like this. When the hypotenuse is the base, it's a little bit harder. I did one in the notes like that. This is going to be a good bit easier because the base and the height are, congruent. So what did it say? R is, the region R. So the base of your shape is going to be upper minus lower. The upper is the parabola. The lower one is the exponential. So it's going to be 5 minus 2x squared minus 3 to the x. So again, upper minus lower. And then I'm ready to set up my integral. We want it to be the same boundaries as we had here because we're using the same region. It was region R. Inside of here, we want the area of our shape. A triangle is 1/2 base times height. The base and the height are both going to be the same, though. So instead of writing it twice, I'm going to just write squared. And it says write, but do not evaluate. So that is the answer. You don't have to actually type it in.